Okay, so this video is for the Coordinate Geometry Mentor Series questions. For question 13, part A, to find the equation of AC, we see that we are already given coordinates of 2 points, which is more than enough, which is sufficient for us to find the gradient, and therefore using substitution of one of the set of coordinates into y equals mx plus c, we will find the y-intercept. Okay, so for part A, gradient of AC equals to 6 minus 0, 3 minus negative 9. So rise over run 6 divided by 12. Okay, so that gives us half. It's positive, which makes sense given that it is sloping upwards. So substituting, for example, coordinates for C into y equals mx plus c, we have 6 equals to half times the x value plus c, giving us c equals to 4.5, that's 9 over 2. So AC, y equals to half x plus 9 over 2. And now for part B, in order to find the length of AB, I require the coordinates for point B. We know that point B lies on the y-axis, so B should have an x coordinate of 0 and its y coordinate, since this is a trapezium, OABC is a trapezium, therefore AO must be parallel to BC, which means that the y coordinate for B will be the same as the y coordinate for C, 6. So let's put those in. And now we are ready to find the length of AB. We're going to be using Pythagoras theorem since we know this is a right angle, and that is how we derive the length of a line segment. So 6 square plus 9 square. This gives us square root of 117. Get the answer, round it off to 3SF, 10.8 units. Now part C, a point D lies on the line AC, such that it is equidistant from both x and y axis. Okay, this portion over here, a point that is equidistant from the x and y axis, if you remember our drawing of diagrams, which we learned in lower sec. So this being our y-axis and our x-axis, a point that is equidistant from two lines means it must lie on the angle bisector. Okay, so the angle bisector will look like this. And this line has the equation of y equals to x. Okay, so 45 degrees over here, 45 degrees over here. Any point on this line y equals to x is equidistant from the x and y axis. So apparently a point D lies here, and it also lies on the line AC. So we are now trying to solve a pair of simultaneous equations such that this red line, y equals to x, will intersect our line AC. Okay, so if we extend the line long enough, they will eventually intersect somewhere here. Okay, and we require the y value. This will be our point D. So doing the simultaneous equation, I've got AC equation to be y equals to x over 2 plus 9 over 2. That's equation number 1. Second equation, y equals to x, equation number 2. Continue to solve them simultaneously, we get x equals to 9, and of course y must also be equal to 9. So D will be 9, 9. Okay, now in the last part of the question, part D, there is a point E on the x-axis such that ABCE is a trapezium. So let us choose a random and arbitrary point. Let's call this point E, such that we have ABCE as a trapezium, and the area will be 27 square units. The formula for the area of a trapezium is given to be half times the sum of the parallel sides. So these are the parallel sides. The length over here is simply 3 plus, now the length from A to E we do not know. Okay, so let the coordinates for E be, for example, x, and the y coordinate will be 0 since it lies on the x-axis. So in this case, the length of the longer parallel side will be x minus -9. Okay, so this part is the length of AE. Then we have to multiply this by the perpendicular height, which is given to be 6. Where's the perpendicular height? It's found here. And this is supposed to give us 27. So with one equation and one unknown, we should be able to solve for the value of x. So dividing by 3, because half times 6 will be 3, divided by 3, we get 9 over here. 3 plus x plus 9 equals to 9. So from here we see that x equals to -3, which means that x will be lying on the left hand side of the diagram. So point E will be -3, 0, which means that I will have to revise my diagram drawing. Point E is no longer here. It is in fact over here. Okay, so ABCE, still a parallelogram, still a trapezium, but the area 27 square units. Right, so this is a parallelogram. Point C has x coordinate of 13, let's call it y. Don't know the y coordinate. Okay, let's just call it YC. Okay, so YC. Then we also have the equation of AB and BC. Now if we are given the equation of AB and BC, we therefore will be able to get the coordinates of B by solving simultaneous. Okay, so now gradient of BC, since the equation of BC is 3y equals to x plus 14, rearrange this to become y equals to x plus c, so 1/3 x plus 14 over 3. This will now be the gradient. Gradient BC equals to 1 over 3. Okay, so now for part. Okay, so since BC's gradient is 1/3, then this must also be the gradient of AD, since it is a parallelogram. So this one, gradient equals to 1 over 3. So part B, as expected, we have to find the coordinates for B. So y equals to 2x minus 7, equation number 1. 3y equals to x plus 14, equation 2. So 1 into 2. So 3 times of 2x minus 7 plus 14 6x minus 21, x plus 14, 5x, 35, x equals to 7, y equals to, sub this back into equation number 1, 14 minus 7, we get 7 again. So for B, 7, 7. Now to find the length of BC. To find the length of BC, I require the coordinates for B and C. Currently, I only have the x coordinate for C. I still require the y coordinate for C, which is simply obtained by substituting the x coordinate of 13 into the equation BC. Okay, so doing that will allow us to find the y coordinate for C. Therefore, y coordinate for C equals to, 3 times the y coordinate of C equals to 13 plus 14, that's 27. Y coordinate for C will therefore be 9. So we update this to become 9. And now we are ready to find the length of BC. So BC, 13 minus 7, we get 4 square. 9 minus 7, we get 2 square. So 16 plus 4, 20. Root 20, get an answer, rounding off to give us, so this is not 4 square. 13 minus 7 will give us 6. So 6 square. The square root of 40. Get an answer, rounding off to become 6.32 units. And now for the equation of CD. Earlier we said that BC is parallel to AD, so this had a gradient of 1 over 3. To find the equation of CD, you need either two points with their coordinates or 1 point with the gradient. Okay, so this gradient not useful for us. Rather, the gradient for AB will be useful for us. So the gradient of AB, we see that it is clearly 2, which is equal to the gradient of CD, since it is a parallelogram. So do the substitution. This is our only known point. 9 equals to 2 times 13 plus C. So C must be 9 minus 26 to give us negative 17. So CD has the equation y equals to 2x minus 17. And for our last question, point A, 3, 5, point B, negative 2, negative 7, point C, negative 2, negative 2. So we notice that they have the same x coordinate, which means that the line BC over here is a vertical line with the equation x equals to negative 2. Okay, now let's find the equation of the line AC. With two sets of coordinates, I must be able to write down the gradient, do the substitution, get the equation. So for part A, gradient of AC. So that gives us 5 minus negative 2 over 3 minus negative 2. We are expecting a positive answer. So this is 7 over 5. We do the substitution for any cell point A or C. So let us use point A. Y equals to gradient times the x value plus C. So the y-intercept is given to be 5 minus 21 over 5. To give us 4 over 5. So the equation of AC is y equals to 7 over 5x plus 4 over 5. Now for part B, the area of triangle ABC. You have only learned one formula for the area of triangle so far. That is half times the base times the height. In this case, we've got 3 options for the base. And we've got 3 options for the corresponding height. Only one of the 3 sides is suitable for us to use as the base for this question. Okay, so if we choose the base to be BC, if this is our base, then you must be able to identify where the perpendicular height is. So for this type of question, we always make use of this property that it is on that the whole triangle is on a Cartesian plane, where we have the x and y axis being perpendicular to each other. So the coordinates are very useful to help us determine what the corresponding perpendicular height is. So let's continue this line up. If BC is my base, then my perpendicular height will be the point that wasn't used, which is point A, down this way. And we are able to find out what this perpendicular height is, since this is x coordinate is 3, this x coordinate is -2. So quite clearly our perpendicular height is 5 units. Okay, 3 plus 2. So let's continue with the formula. The base being from -2 to -7, that's 5 units. The perpendicular height, we also mentioned that it is 5. So we get 12.5 square units. So this was our perpendicular height. Now next one, to find the exact perpendicular distance from C to AB. We need to be able to identify which distance are they referring to. From point C to AB, the exact perpendicular distance. So what would this be? If we know the coordinates over here, then we can use the formula for the length of the line segment. But we don't know the coordinates over there for now. You could find out using your A-maths knowledge. Since I can find the gradient of AB, I can find the gradient of the perpendicular line. Once I have the gradient, substitute in the coordinates of C, get the equation, and do simultaneous equation with AB, then find the length of the line segment. But there is another way, which is to use the area of triangle ABC. And this is the method that we often use for E-maths, when we try and find the perpendicular distance from a point to a line for triangles like these. Okay, so this triangle, we found that the area is 12.5 square units. If AB is the base, then our perpendicular height is exactly what question C wants us to find. And since the area doesn't change, it is the same triangle, we know that half times AB times whatever they want us to find must be equals to 12.5. Okay, so let's put that all down. For part C, let perpendicular distance be h. Okay, so let this be h. So half times of AB, that's our new base, times h has to be equals to 12.5. Let's do a substitution in. Have we found the length of AB? No, we haven't. Okay, so now let's find the length of AB. For the x, the magnitude of x will be 3 minus -2, which is 5 square. 5 and then we square it. Then plus from 5 to negative 7, that will be 12 units, and we square it. Okay, so this is my length of AB times h equals to 12.5. Multiplying by 2 throughout and evaluating 5 square plus 12 square, that's 169, square root, get 13. So in the bracket is 13h equals to, multiplying by 2 throughout, 25. H must be equals to 25 over 13. Then that's our perpendicular distance. And finally, to find sine of angle ABC, angle ABC is found here. We don't have to evaluate the angle first. So sine, for part D, sine ABC opposite. The opposite side, we know is 5 units, divided by the hypotenuse, which we found in part C. That's the length of AB, which is 13. And that's the answer.